Welcome to JF Green Energy concept. We've been talking about the pulse motor system. Today we want to look into one of the critical components that make up this pulse motor system. It should be the least or the smallest component in the videos in the pulse motor setup. But I think it should be. It is the one of the most important components here. So the Hall effect from this diagram, we want to give you a detailed analysis of this component. Now, it is a three legs this component, just like your transistor. It is written 3144. Now, this component has three legs. The first one, just as you can see there, the first one there is the input. The second leg is the negative, while the third is the signal. Now, one thing you must know about this component is that this is connected to the battery through 1K resistor. Now we are using a 24 volts battery in this circuit. For the pulse motor, you can actually design this with a 12 volt system. It will all work. Now the positive goes from 1K to the first terminal of this transistor. The negative goes straight to the negative, which is the center terminal of this Hall effect. Now the signal, which is the third leg, goes directly through 1K to the gate of your MOSFET. Then the drain goes to the coil. Then the second terminal, which is the source from your MOSFET, goes to the positive. Now, if you are not conversant with how these things works or how they operate, it will be difficult for you to operate. Now, this is your MOSFET. We are using a P-channel MOSFET. The first leg of this MOSFET is the gate. The second is the drain, while the third is the source. The MOSFET we use here is a 9540 IRF 9540. It is a P-channel MOSFET. You can use this or any other P-channel MOSFET. Now, for the people that are not well grounded in electronics, this first terminal here is the gate. That means the signal coming out from this third terminal of your Hall effect goes to the first terminal through a 1K resistor. Now, the third terminal of this MOSFET is the drain. It goes straight to your coil, your trigger coil or your starter coil. Then the third goes to the positive. Remember, it is a P-channel MOSFET. P-channel in the sense that it operates just like your PNP transistor. The positive gate and positive drain and positive source with a negative gate. That will now show you that the signal coming out from this Hall effect is a negative signal. Therefore, it must be powered, it must energize a negative sided or a negative minded MOSFET. That is why we use this P-channel MOSFET. Now, using our breadboard to experiment, we did all the configuration. Don't mind this. This is just a transistor experiment. the transistor experiment. So for this, we have a Hall effect. You can see it is on when you apply. So what we did here, let me remove the amplifier. Okay, here it's like this one is an external version of the MOSFET. So this is your 1K resistor, goes to the first leg. The third leg is the gate, is the drain, while this is a source. If you check, this goes to the positive of this battery. Then this one is the output through this resistor, is showing you connected through this bulb, then to the negative. Now the signal that actually, okay, this is the signal coming from the output of this Hall effect through this. So this LED bulb here is just an external indicator showing us sorry, it is an external indicator. So once that blue light is on, it means if you connect it to the coil, it will energize the coil. So you can use this to know the exact point when your trigger coil will be on and how you can switch on this circuit. You can actually use this thing for a whole lot of experiment using this magnetic Hall effect sensor switch. So this is how we do it. We did it. Let's uncouple this, the amplifier. So remove this so that we can explain. Okay, so this is your Hall effect, the three terminal system. The first is the positive, the negative, and the output. Now from this battery, this is a positive terminal. We're using this side as the positive. Now we connected a 1K resistor to this leg. Then this is serving as our negative terminal. So we connected from this negative to the center of the Hall effect. Now, because the Hall effect generates a negative signal as output, if you are using an LED to experiment to know what, okay, to test the circuit, it means the negative side of the LED goes to the output, while the positive is connected through this resistor, then down to the positive terminal, so that we are just using this as a testing lamp for this Hall effect. So when a particular side of the magnet approaches the Hall effect, it will trigger the system. So when you reverse it, nothing happens. So if you can do this setup, then you are halfway towards your so this is the component. This is how to set it up. Then the other side is the amplifier. So for this, we have this as the component. Then this is the whole setup, a detailed analysis of this and how to work with this Hall effect. So what we are looking at in detail is just this side of the component, the Hall effect, and how to place it. So this is your Hall effect. If you turn it, there is nothing written there. The front is where you use for your connection. So when you place it, you can now choose, actually determine which is the positive, the negative, and the signal. Mind you, the signal coming out is a negative signal. So that is it for today. Join us as we continue in this match. One thing we promise you is that if there is any means or any system that can give you an over unity, believe you me, it has to be a pulse motor system. And for us, we have gathered all the necessary information that will help you achieve that goal. Thank you. Make sure you subscribe because greater things are about to happen. From JF Green Energy Concept, see you next time.